Right. Talking about exponents and logs, I would like to, at the moment, to just focus on few rules of exponents, and let's see what kind of rules we get in the logarithmic language. Okay. So in this case, let's say exponents, and this side I'm going to say logarithmic. I'm just going to write that, and then let's have a kind of a partition here. Now, first of all, let's say we've got m, which is equals to a to the power of x, and we've got, remember what we said before, this is important. We said if we've got something like this, this is the same thing as saying log base a of m is equals to x. Then if we've got n being a equals to y, same thing can be translated to logarithm language and say log base a of n is equals to y. All together. In such a case that if I tell you that this is a number a to the power x, that is m, is it? That is m, is it? So if I multiply this number by a to the power y, that is n. Which means here, in logarithm, let me say here, I've got m times n. Sometimes use a dot, just a dot like that for multiplication. So which means I've got this. Now if I got this in rules of exponents, we know that we say this is a to the power x plus y. Altogether. So this is a to the power x plus y. So now, if I'm now going to say logarithm what's going to happen now? I have to look at the m times n, which is this. Because remember we said logarithm is asking you what is the power to which you elevate a to get m plus n, m times n. But m times n is this. So what is the power of a? It's x plus y, isn't it? So we then say this is equals to x plus y. Then, but x plus y, x itself alone is the logarithm of m. And the y on its own is the logarithm of n. What does this mean? Just this part and that part, they are equal. What does it mean? It means that a log of a product is the sum of the logs of individual numbers. Then it means that one day I can be given this and be asked to express it just using one log. My friend, go to page 1 of this compilation of exercises, 1, you will find that expression. Express logarithm of x minus logarithm b logarithm that as using a single logarithm. So you're using that property. Then after that, you go to the textbook. Then let's come to the next thing. Then we come to say, let's say we're talking about a to the power of x over a to the power of y. What is that? That is m divided by n. If you remember the rules of exponent, this says a x minus y. Isn't it? So now if we now apply log here, base a of this quotient, we need to know that this is m over n. Its logarithm is that exponent there, isn't it? So then we say x minus y. Then this is equals to log, I'm not going to repeat what x is, we all know now. Log of m, am I right there? No, good. So log of m minus log base a of n. What is that saying? Exactly the same thing. The log of a quotient is the difference of the log of the individual functions. But you must know, remember the subtraction has got an order. 2 plus 3 is the same thing as 3 plus 2. But subtraction does not follow that, isn't it? So you have to see which one is being subtracted. The order is very important there. All together. Then the other property which I need to look at, which you need a lot, is this one. Let's say now I've got a to the power y, this elevated to the power p. According to rules of exponent, this is the x a to the power p y. Yp py is the same thing. Is it correct? Now, if I now do that, you can see that this is actually n to the power p. Now, if I now apply log base a to m to the power p, what is going to happen here? There is the log. Is it? Altogether. So, then this is says p y. But what is y? What is y? So this is p log base a of n. What does it say? If I get a number elevated to a power like that, to get the log of that power, I can first just find the log of n multiplied by p. I've got that log. Are we together, guys? Okay. Again, I don't know whether you understand me when I'm saying this thing. When you are looking for a log, you are actually looking for a power, for the exponent to which you elevate the base in order to get the number for which you are calculating the log. Am I making sense there? Do you hear what I'm saying? I'm looking for log of n. I'm looking for, let's say here, I'm looking for the log of m. I'm looking for the power to which I elevate this base in order to get m. And that power, that base is here, is elevated via x to get m. So that's why I'm saying here logarithm is x. So now answer me this question. To which power would I elevate a in order to get 1? It's not the first time I'm asking this question. 0. So what does that say? It says here logarithm of 1 to base a is equals to 0. That is important to me. Now, to what power can I elevate a to get a itself? 1. Then that's telling me that logarithm of a base a is equals to 1. That is very important to know. Are we together, guys? Okay, questions there? If there are any. Something which is not clear. So the rest, I'm just picking on a few properties of exponents and trying to parallel them with similar properties of what? Of logarithms. So now here, we have to add the log of a base a will always be equal to 1, and log of 1 base a will always equal to be 0. You are going to need some of these things in order to simplify in some situations. Yes, sir. The reciprocal of log. Can you write that on the board? Can you write that on the board, please? Right. Now what I want to do now, I want to just look at a few examples involving the properties we've been just discussing before. That's right. Then let's look at this one and say log of x minus b log of y plus a log of z. And the instruction here, you must express this thing using only one log. All what you need to do, you need to go back to those properties, and if you've forgotten them, if you're doing exercise, then you spend time with it. You need to play your video clip a bit, recap, and do things. What you'll be doing there, you'll be repeating, because human beings learn by repeating. Okay. But don't repeat the course. Okay. So what do we have here? We have log of m to the power p equals to p log of m. You have log of mn equals to log of m plus log of n. You have got log of m over n equals to log of m minus log of n. Listen guys, when you're doing an exercise, what I'm trying to do here, I'm not really necessarily saying you must write as I'm writing. I'm just writing because sometimes if I say it by word of mouth, you might not see what I'm talking about, isn't it? So these things are going to apply each time we need them. So I think for the first time, we need this one. Altogether. And we need 2 points. Where? Here and there. Altogether. Then we say log of x minus log of y power b. Oh, sorry, power b. I will change that to b. Log of z power a. Power a. Something is happening very fine. Let me just get rid of this. That log of what? Of y power b. Is that right? Okay. Now, what do you think? What takes precedence? Multiplication, addition, or subtraction? Which comes first? Hippopotamus. Addition. We'll talk about addition and subtraction. So we'll take the addition terms together and they say log of z power a minus log of y power b. Do we agree? Okay. Then after that, I think now we need this. Altogether. As you can see, as I move the step, I think about which property do I need, what do I need, and if you do it without doing exactly that way, definitely somewhere you're going to just push things mechanically, and they will end up mechanically and mathematically wrong. So what's going to happen here? It's m over n. What is m? What is our m here? What is our m here? According to the property. What is our m? X. N is that one. So this will come to log x za minus log y b. You see what we've got now? We've got 2 words log, but you need 1, isn't it? So what do you need now? That one, isn't it? So there is that one. They just came in the order which I wrote because I saw the thing, I looked at it, I said, okay, you need 1, 2, 3. I just put them down. But you don't need necessarily to write them down, but you have to have them into account. Don't overlook them. Then after that, I think everybody will agree that this is log bracket there x z over y power b, and that we've achieved what we wanted to achieve. Agreed? Then I can come and they say that is correct. Are we fine? Another question? Okay. Then let me check if I can get another example which is interesting here. All these things I'm thinking for page 1 and 2. I would like you to go and check 2.1, which says do this without the calculator. I think I'm going to move to something else now. I'm going to move to equations. Equations involving logs, equations more involving exponents. Remember, we also discussed the natural base. Is that right? The E, the base E, the ln. We talked about that, isn't it? Are you sure? Okay. No, it's fine. If we didn't talk about it, we're briefly going to talk about it now. It's not a problem. Now, let me just continue there and say, now, when we talk of, let me just here, let's talk, say, logarithms. Logarithms. When we talk about logarithms, when you write something like this, log, normally, now everyday use, we mean log. I'm not saying equals there. So it means log base 10, because our usual base is what? 10. But if you check in your calculator, there is a certain key which has got something like this on your calculator. And the second function of that is something like that. Maybe they let's say lin x, then they put something like that there. Or just e and lin. Now, what did I say? What is the inverse of an exponential function? Logarithm function, isn't it? This is a logarithm function. When we write this lin this way, we actually mean natural logarithm. This means natural logarithm. Why is it having NL? I think there are many reasons for that. But my reason, which makes sense to me, this is not English. This is a language which has got its origin in Latin. I'm talking about language like Spanish, Portuguese, French, and all those things. They don't say a beautiful girl. They say a girl beautiful. Una muchacha bella. That's a beautiful girl. Una muchacha bella. That's a beautiful girl. So what happens? The adjective which describes the noun comes after. So the noun is logarithm, and that is that. So in the Latin languages, this is logarithm natural. That's how it is. Okay, so this is not English. Okay, so now what is this? If I write something like this, ln of x, I'm just having a shorthand of writing logarithm base e of what? Of x. Then what is e? E is a number, irrational number, like pi. This number, I think, was familiarized by one guy called Euler. Again, that is not English. English people will say Euler, like in Europe. So, in honor of this guy, this number was given this e. Why natural logarithm? Because this number e comes up naturally in describing a lot of natural processes, including population. Population of a certain locality can be described by function P0 e to the power kt. This k coefficient here is got to do with something called the population growth rate. In electricity, if I'm not mistaken, you get some in a circuit which involves a resistor and an inductor. You get that the current is actually equal to, I think it's V over R something brackets 1 minus e to the power, I can't remember the coefficient there, but something like that. But I will show you when I get that. So again, electricity is something natural, and that number is coming there in a natural way. So this E number, the number which was made familiar by this Euler, is a number which comes out in natural processes. Then it justifies calling any logarithm, the logarithm to its base, natural logarithm. The rules of this natural logarithm are going to be exactly the same. So in other words now, I'm saying ln of m, n, is equal to ln of m plus ln of n, and the rest follow. Are we together, guys? Okay. So now, what I wanted to do, what actually now wanted to do, having logarithm functions, having all these rules of exponent, we can now talk about equations, exponential equations or logarithm equations. Okay. Let's come and say equations. In this case, I'm not going to describe them, but we know we're in the context of logarithm function and the exponential function, so the equations are the ones which correspond to these types of functions. Now, some people don't really understand what are equations. I know that. If I've got a function here, let's say this function is 2 to the power x. Then I tell you somewhere, let's say I've lengthened this line up there. Let's just cut there. That indicates that I've stretched the line high. So somewhere high there's 84. Oh, sorry, I meant to say 64. 64. Then that value, if I draw horizontal there, you will see that there's a point there, y, which corresponds to 64. Now, when I start looking for what is the value of x here, asking for this value here, I'm actually creating an equation which says 2 to the power x equals to 64. There are two ways I can solve this equation, or more than two ways. But one way of doing this is to say now, take the log function, even that base 10, and say 2 to the power of x equals to the log of 64. What do you need here? You need that the power property. What's going to say? It's going to say x log 2 equals to log of 64. Remember, log of 64 is a number. Log of 2 is a number, isn't it? Then therefore, x equals to log 64 divided by log of 2. Not 2, divided by log of 2. All together. Then you can go to calculator and simplify. Then you can give the number of decimal places maybe which are specified, or just choose your own. The other way is this one. The cross, the famous cross, can be used in mathematics. 64. The base is 2. I take 2, divide that 2, I get 30 what? 32. I divide 2, I get what? 16. I divide by 2, I get what? 8. I divide by 2, I get what? 4. I divide by 2, I get what? I divide by 2, I get what? Then that one says stop. Altogether, once you see a 1 coming up as an answer, says stop. Then what does it say? It says this 64 is 2 to the power 1, 2, 3, 4, 5, 6. Then I compare, the bases are the same, the exponents are the same. Therefore, x is equal to 6. If you don't get x is equal to 6 here with your calculator, you tell me. I'll stop teaching mathematics. Altogether, that's what you must do. But any other number which is not like 64, definitely you're going to come up with decimal numbers here. Log of 2 base 2. Sorry, log of 2 base 10. I don't know what it is. Log of 64, I don't know what it is. You get it from the calculator, but in the final analysis, that should give you 2. Is it giving 2? Sorry? Oh, 6, man. I'm sorry. I want to say 6. 6. The other way you can do it, actually, 6 to the power 64 is 2 to the power 6. So you can say here, log of 2 to the power 6 over log of 2. We bring that to this side, we're left with the log of 2 over log of 2. A number over a number is 1. So we're left with 6 times 1, which is equal to 6. What do you want? Complaints? Are you understanding, guys? Okay. So that's how the equations come about. So you can also remember the inverse of the exponential function is the logarithm function. So if you pick a 1 there, we've got a function there, logarithm. Now let's talk, maybe say logarithm base 2 of x. We can also take a number here, maybe there, say that we search for this x here. Then we can create an equation. If we know this, let's say this is minus 1 here. Then we end up here, minus 1. Want to see what that x. Then we set up an equation that says log base 2 of x equals to minus 1. Then we play around again using the same properties. We must come up to a value of x. All together, guys? Okay. Let me then take another example from the book here, from your compilation of exercises. Let's say clean up. Then next example. Now I want to take one which involves lim. Here it is. It says lim of 5 minus 2x equals 2 minus 3. I need to get somewhere to say x is equals 2. Then I will say I've solved the equation. Now, remember what I said before. I said this concept of an inverse of a function is the concept which makes solution of equations possible. Do you remember that? Do you remember that? Okay. So now, I need x, and you can see that x is under lim, or it's under log. So to unwrap it and take it out from lim, I need the inverse function. What is the inverse function? The exponential function e. So what I'm going to do here, I'm going to say e to the power lim of 5 minus 2x equals to e to the power minus 3. The problem is, whatever you do on one side of the equation, you must do it on the other. It's exactly the same way. But this side, a function composed with its inverse. Now it's f minus second function composed with f of x. It doesn't matter whether we're in Japan, Honolulu, or Hong Kong. This will be equal to x. What I'm saying, mathematics is universal. It's not like Zulu, which you're going to speak in Zulu, in KwaZulu Natal and in Gauteng, and break it in Gauteng into pieces. Mathematics is universal. Altogether. So this is universal. So now what is going to happen here now? Because of that, this is f second function. I'm going to have f5 minus 2x equals to e to the power minus 3. This is a number. Don't worry about it now. The exercise says give this answer to 4 decimal places. So wait until it's the right time to use decimal places. So don't introduce decimal places yet. Because if you put this on calculator, it's going to introduce decimal places, and I think it's too early. I'll explain why I'm saying that. After that, let's add minus 5 on both sides of the equation. What are we going to have? We're going to have minus 2x, because minus 5 plus 5 is going to be 0. 0 plus minus 2x is going to be minus 2x. Then e to the power minus 3 minus 5. Remember I said to you, in my class, nothing moves across the cosine and change sign. Things don't move here. What do? We do an algebraic transformation. Altogether. It appears to you like it moved. Don't think it has moved. Because things which appear like as if they're not exactly that. Okay. So now what do we do next? We need to divide both sides by minus 2. Reason? Because we've got multiplication nearby, minus 2. And the multiplication is the inverse operation of division. So we introduce division, you get x, then you get e to the power minus 3 minus 5 over minus 2. Then you can simplify this to 5 minus e to the power minus 3 over 2. Then you can go to your calculator. Then if they say give the answer to 4 decimal places, You write whatever whole number is here, then you get places, place, that's 4. You cannot do that. Then you get place, maybe 5 or 6, you stop there. That's your answer. Then you say now, therefore, x equals to, you then round off this number to 4 decimal places. I hope that you know how to do it, isn't it? Then you write this thing here, then you say 2, or correct to 4 decimal places. Please write that. Altogether, answer the question fully. Write that. The answer for that calculation is here. And it normally, the calculator, I think, will almost, for this number with E like this, I'm telling you, all the places in the calculator will be covered. And there will be still some digits which are left. So just copy those 4, 5, 6 decimal places, then you round off to 4, then you write correct to 4 decimal places. All together, guys? Okay. I think what I'm going to do now is the last example on these equations. All together? Okay, let's do this. Or before I say that, are there any questions before I proceed? Now, this is the last example on equations. Now, this is an exponential equation involving base E. We need to find out what is x. Right. Then, what we need to do here, we need to find the x. I think the first task we must do, we must leave the expression, the term or the expression with x on one side of the equation. So what does it tell us? We must add here 7 on both sides. Then we get E, 2x plus 3 equals to 7. Because we have got E here and we want to free that thing, we need to call on the inverse of E. What is the inverse of E? Then we need to apply ln on both sides. Then you come here and say ln E 2x plus 3 equals to ln 7. This does not look like a 3. So let's say the plus 3. What's going to happen here? This argument of E, because this is function, this is inverse, going to drop down as 2x plus, no, maybe let me not do that first of all. Let me not do that first of all. Well, there's something I want to highlight here. Let me not do that first of all. Let's use that power property. The power property will say this is 2x plus 3 brackets ln E equals to ln 7. But what is ln E? Ln E is logarithm base E of E. What is that? 1. That's why I wanted to highlight that. But in future, you can just drop it down like that, isn't it? Knowing what happens. So this is 1 times that, you're going to have 2x plus 3 equals to ln 7. Because sometimes we've got a tendency of focusing on shortcuts and then we miss the broader picture, isn't it? Yeah, so I'm not going to fix it. That's why I reversed that thing and put it there so that you can understand, get the broader picture. So after that, we need to leave a term with the x on one side alone. We've got 2x plus 3. So 3 is a problem there. So we call upon his friend minus 3 to create a 0 here and be left with 2x. Isn't it? But what we're going to do here, we're going to do that side. So we come here and say 2x, what has happened? 3 plus minus 3, 0. 0 plus 2x, 2x. Am I making myself clear? On the right hand side, ln 7 minus 3. What do we need? We need x, isn't it? Then we need to divide both sides by 2. Then we have that ln 7 minus 3 all over 2. Are we together? Okay. So guys, what is left to you now is to go to the comparison exercises and the practice. And the English people say practice makes perfect. In Soto they say anyane anyane ki ahul. I'm not going to say what they say in Zulu and Xhosa. So thank you for listening that far.